Let's configure the rendezvous point configure. Let's remove the rendezvous point configuration from every router except R3. Sorry, R9. R9 is the rendezvous point. So that static configuration show run section IP PIM RP address. I'm going to remove this from every router except router 9. I'll use the notepad. Okay, 9 I'm not going to remove. I'm going to remove from 10.
I'll be right back, brother. Just gonna pick up a package.
So
1
other than
second.
router 9, we have removed from all other routers. So if you go to router 10 and ask show IP PIM RP, it still has got this. The reason is for this multicast address, it has already learned. So we have to clear IP PIM RP mapping. Okay. So there is something else. Clear IP M route start. I'm clearing the routing table because from there also it may tick. Okay, this is the Cisco's auto RP using the RP. So I have to do something more to clear this. It's learning from some. Okay, gone. Sorry, not gone. It learns from somewhere. Show run. Show run section. Oh, still there. How is that possible? I said no. Oh, there is no in it. There is no in it. Funny, Jay. Brother, did you see the mistake that I did? Still funny, no?
No, no problem. Yeah, that happens to me. Forgetting the no somewhere. That makes sense though. That's good. Yeah, I'm jotting down the commands.
Okay.
It's good to do it while you do it. Yeah.
Okay. So now let us go and check show IP PIM RP. I should not see anything. Okay, I'm not seeing anything. RP is removed. None of the router except router 9 knows RP. RP Router 9 itself is an RP, you see. Router 6 knows about there is a multicast group member, like 5 and 8 are multicast group members. But router 6 don't know who is RP. Router 5 also don't know who is RP. Go to 5 and check. It says, I want to join this group, but I don't know who the RP is. So R5 cannot send any request. Right? If I check the same on router 9, it says I know RP and myself is the RP. Router 9 is the RP himself. Show IP interface brief. You see? Because it is RP, it will create this tunnel to negotiate. Now, to distribute this RP, to distribute this information that router 9 is an RP, there are various ways. The best way is using the PIM which is already working to distribute. So before I do that, one more time, I would like to take you to one of the router randomly. Okay, I'm on router 9. Show IP PIM RP. See, there is no RP. But after I put 2 lines of configuration on router 9, you will start seeing RPs on every router. If there is no RP, then there is no chance of pinging. So if I ping, what's the multicast address? 239.1.1.1. We will not be seeing any reply from
One,
anywhere.
one. Yeah.
But after I say IP PIM BSR candidate loopback 0 and then IP PIM RP, not RP candidate, IP PIM. One is BSR candidate. Okay, correct. RP candidate. RP candidate loopback 0. After I say this, see 2 commands. One is IP PIM RP candidate. This is to say whatever the address that you see in loopback 0 is the RP's candidate's address. And then I said bootstrap router, meaning this is the one that BSR need to advertise to everyone. So the bootstrap router is the one which makes the PIM to advertise the loopback zero's IP address as the RP's address to everyone using the PIM, which is already working on the links. As a result, if I go now to router 10, you can see it now. You see the tunnel is up. Now go to router, any router that you want. See, you can see the tunnel up. Earlier it was 000, but it now knows it. If I go now and ping, I'll get a reply from wherever the IGMP for 239.1.1 is configured. So router 8 is responding. I think the other one is router 5. Why I'm not getting from 5? 5, where are you? 5 knows it, but why I'm not getting reply? I'll be getting reply from 5 also. Let's go to 5 and check once. Hello 5. Show IPM route. Router 5 says, I do receive the packets, the multicast packets from 11111 on this interface. And I'm forwarding to the loopback. That's right. So there's no doubt. Router 5 is receiving it. For some reason, the ICMP reply is not coming through. Oh, here it is. See how
Oh yeah, there
quickly
you go.
the distribution of
Nice.
RP is done. This is the best way using BSR, Bootstrap router, to distribute the RP info. This is a scalable version. You cannot go to every router and put the RP address. And we cannot go and delete when there is a change in the RP. Auto learned. The other one that I want to show you today is having multiple RPs. If I make router 9 as an RP and then and then and then router 3 as an RP, what will happen is these group members will come and register themselves with 3. And the source will register with the okay, not 3. I don't want a 3. I want another router. I'll do one thing. I'll put a wire here between 4 and 6, and I'll make 6 as an RP. Why I'm doing that? The closest will be the chosen RP. 8 and 5 will choose R6 as an RP. R1 will pick R9 as its RP. So we have two RPs. One is R9 and R6. Problem. But I don't know whether I can add it now.
Oh, I need one more interface. Yeah. Let's see. Maybe. Let's see.
Yeah. So I'm going to say here
Baseband.
46. And I'm going to put the IP addresses and run ISIS. Fine, so we're going to do that. Meanwhile, as it is booting, the idea is having multiple RPs, because if I have only one RP in a large environment, having one RP is not advisable, because every device needs to come to that one RP to register in one corner. So instead of that, we keep more than one RP. I'm going to make this and this as an RP. So the closest RP will be elected. So this will choose this as an RP. This will also choose this as an RP. And these two will come and say, I want to receive traffic from the source for this multicast address 239.1.1.1. So this 8 and 5 will come and say via Ethernet 1 slash, is it 1 slash? Yeah, 1 slash. Ethernet 1 slash 0 is considered as outgoing, and Ethernet 0 slash 2 will also be considered as outgoing, because these are the two places from where the members are coming. So when the traffic comes, this is the outgoing interface, this interface and this interface. So but there is no incoming. Source is unknown. S comma G. Source is unknown. But the source here, when I try pinging 239.111, this goes and registers. So this guy says 1.1.1.1 is the source for group 239.1.1.1, and the incoming interface is Ethernet 0. So this router 9 don't know the outgoing. Router 6 don't know the incoming. Router 9 and router 6 need to get merged. For that, I'll go here and say, hey, router 9, your MSDP peer, multicast source discovery protocol peer is 6.6.6.6. And I'll go to router 6 and say, hey, your MSDP peer is 9.9.9.9. After I say that, these two will get merged. So 6 will know that the source is 1.1.1.1. And now router 6 says I have some outgoing interface. So it may use this path to inform that. So router 9 says Ethernet 1 is the outgoing. And like this, the source will be learned. Once the source is learned, the source will be informed to 5 and 8, and the session will be built using their own routing table, the shortest path. And the ping will happen. This is what we are going to achieve now. How do we do this? Before we think about MSDP, we need to see how this multiple RPs can be deployed. I cannot have multiple I can have multiple RP, but I cannot have different IP address. If I have two different router, then I will have two different IP address for RP, which is not acceptable. We want every router to say one name as RP. So what we are going to do is in both router 6 and router 9, we are going to take another loop back. I'll say 96.96.96.96. Here also same IP address 96.96.96.96. We'll define it as anycast RP. Anycast means we know in IPv6 we learn the closest. So using ISIS, router 5 will see this as the closest, and 8 will see this as the closest. And router 9 will see that same 96, but this router as the closest, not the router 6. After this anycast RP, you do MSDP. Please, sir, ask me a question if you have.
No, the only
It will work.
thing
I'll
that
show
comes to
you. Just
mind
one
is
command,
since you're having
anycast.
the
That's
same
all.
IP.
It will work. So I'm
This
going
is
to
just my
quickly go
curiosity, but I'm
and
sure
configure the new interface
any.
IP address on 6 and 4.
Okay, perfect. Gotcha.
4. Enable config T interface Ethernet 0/3 IP address is 10.46.0.4. IP router. Okay, I need to know the ISIS name. Do show. This is the name. So IP router ISIS. That's it. Likewise, I'll go to router 6. I'm expecting neighborship between 4 and 6. Show IP ISIS. I do have the new neighbor via the new interface. Next. What is next? Next is making two RPs. I'll go to router 9. And I'll remove that command IP pim RP address 9.9.9.9. And also I'll remove those BSR commands that I configured. Do show run section IP ping. These two lines. Done. Now we don't have RP. I can check and show you show IP pim RP. This will be removed soon. Clear IP pim RP. Gone. Hereafter it won't come because there is no RP. Now what I'm going to do is I'm going to create another loopback called 96 IP address IP router ISIS. What is the name? 18R6 Multicast lab. I'll also do the same thing on router 6. Interface loopback 96. IP address is 96.96.96.96. IP router ISIS. Fine. So now if you go and ping or trace route from router 8, which one will be responding from router? If I ping from router 8, do you think router 9 will respond to you? No, the closest. If you ping from router 1, who will respond to this 9696? It's router 9. Let's check. I'm going to router 1 to trace. Router 9 is going to respond to you. See? And if I do the same trace from router 5, who will respond? 6 will respond because 6 is the closest. Brother, do you agree this? You're going to see reply from router 6 here.
Yes, I see the replies. The I saw router 9 respond to R1, yes.
That's it. So it will
Case
always go
route.
to the closest.
Yeah, 4. Oh, wait a minute.
Yeah, it will go to the closest. So if I make this particular address as the
Yeah, the
RP,
next hop will be 4.
the
Next
closest
6, yeah.
will be chosen as an
Right.
RP, picked up as an RP. Sorry.
Now my question was, again, I'm thinking, would this ever create like a black hole or any, because it's the same IP being advertised by the IGP?
I'm not getting
Oh,
you.
I'm seeing not, right? I'm proven wrong, obviously, by looking at the results. But I mean, is there any possibility of that? Or is there a command that prevents it from ever
Hmm.
doing that? Right.
No,
So
here,
in the
no, it's
past,
not like
I'm
that.
seeing that when you have duplicate IPs, right,
Even in the
advertised in
past, you did
different
not have this
locations,
confusion because
they
routing
can
table is
create
going to
confusion
only
in the
pick the
routing. But in this
destination
case, I'm
with
seeing the opposite,
low metric.
because of the,
It
uh,
never gives you conflict. Only in layer 2 you'll have
okay.
conflict. That's a subnetting issue. That's
Because
the
I've seen that
summarization or subnetting
there
issue.
was an issue
That will cause
before
loop.
where
That's a
a
different
group,
story.
one of our teams
Here it's the same IP address, same
did not
slash 32
validate that
on
the
different
subnet they
site.
were using was
Now,
already
what
being
I'm
in
going to do
production and
is
used.
I'm going to go to router 9
Yes. Right.
and now
Okay. Okay.
I'll configure
Okay.
IP PIM RP address, IP PIM RP address as 96, 96, 96, 96. I'll put the same command on router 6. No change. And then I'm going to use the BSR to announce this. IP PIM BSR candidate use loopback 96. PIM version 2 not configured. Oh yeah, we did not enable spats mode. Interface loopback 96. IP PIM spats mode. This is newly added interface. Even on the interface Ethernet 1/0, which is newly added on R6, I need to put this. Likewise on R4 also.
Right.
And also I need to do it on router 9's new loopback interface.
Right. That makes sense.
96. Okay. Now I'm going back to router 6. Then I'll come back to router 9. I'm going to router 6 and I'll say IP PIM BSR candidate loopback 96. IP PIM RP Can IP PIM RP candidate, that's right. Loop back 96. Right, I'll repeat the same command on router 9. IP PIM BSR candidate loopback 96. IP PIM RP candidate loopback. As a result, if I now go to router 1, show IP PIM RP, wait some time, it's going to it will come. Okay, here you will not see unless you add some multicast. Now, let me go to router 8 and show you. In 8, you will see. Show IP PIM RP. You can see this has 96 as RP, but when you trace route to 96, it will not go to router 9. Instead, it will go to router 6, which means according to router 8, router 6 is the RP. Likewise, router 5 will also show the same thing.
Yes.
So if I ping now from router 1, the ping will not happen. The reason is router 1 will go to router 9 and register, whereas 5 and 8 enrolls in router 6. There is no sync. So if I ping now, ping 239.1.1.1, I'm not going to get a reply because 9 do not know the group member, 6 do not know the source. 9 and 6 both are RPs, but they are not. Oh, what is this? I'm getting a reply.
Oh.
No. This is with something old record. So let us clear. Clear router 6 and router 9 once. Clear IP M route. Start. Clear IP RP mapping. Clear PIM even on router 6 without so this goes to router 6 without synchronizing with router 9. You cannot ping from router 1, but it was pinging maybe based on some inputs received earlier, which is still there in the routing table. Clear IPM route star. Clear IP PIM. Okay. So let me try going to R1. I should not get reply. Come on, now 5 only replies. 8 is not replying, that is good. If 5 only replies, then I need to clear this area. I need to refresh this area. This is all coming from the old buffer. It is also coming. How is this? So what is this? Show IP. Let me see how this is happening. Router 9, how do you know the group number? Show IP
Right.
M route. Router 9 says, good. It says I don't have outgoing interface. I appreciate that. It has got only one incoming. Good. That's good. What about router 6? Show IPM route. Router 6 says, I don't know the source. Very good. This is a very nice out. Oh no. Somehow it knows the source as 10.13, this interface. Somehow maybe I need to clear router 3 nicely. Clear IP route, M route. Clear IP M route and clear IP PIM RPM. I'd like to do the same again on R6. Because there's no chance R6 knowing about the source. Clear IP route start. Clear IP PIM RPM.
Mapping.
Show IP M route. I'm expecting. I don't know from where this is coming from. Router 3. Router 3 is not an RP. Who is router 3 to give this? Router 3. How do you know? Show IBM route. Router 3 knows it from router 1. So let me clear. Okay, gone in 3. And also in 1, I want to remove it completely.
Nice. Oh, it's coming again from somewhere. It should not come. It's coming from router 1, but this time I don't think it will come. Again, this guy is declaring itself. But the good news is there is no outgoing interface. Okay, Nice.
these two interfaces are active. The good is there is no outgoing
Oh,
interface yet. Now go to router 3. Again, it is locked.
oh, I see.
We need a bigger topology. This convergence is not possible practically without synchronizing. So in order to synchronize, we need MST. But I already seeing synchronization via one particular. I do one thing. I'll shut down this interface. That's the only option to stop this. It's illegal. Interface Ethernet 00. I'm shutting down. Only this interface. So that the show IPM route. It's learning like this. It learns like this. I have to clear all the routers then. No, I don't have that patience. So let me straight away go to MSDP. This is the configuration for MSDP. First of all, we need to say which interface will be used as the MSDP source. We are going to use loopback 0. You understand? Loopback
Wow.
96 we are using as RP. So I'm using the other loopback interface. So I say IP MSDP originator ID. Yes, originator ID is loopback 0. And then IP MSDP peer. Who is my peer? 6.6.6.6.
Yes.
I want to connect using loopback 0. That's all. I'm going to repeat the similar
Right.
configuration on router 6. And then IP MSDP peer. Who is the peer? 9. And then source. Connect source. Loopback. Now you will see MSDP neighbor. Oh, look at this. Neighbor has come up. So then they synchronize. So now if you ping, then it is reasonable. You should get response from 5 and 8. 5,
9 in this case.
5.
Yes.
So this many paths via which the 5 is responding when you send one packet. Earlier there was only one response because there was not fully converged between there was no full synchronization between 9 and 6. But now you see more output. So this is the right one. Okay, so what is left is one more called auto RP, which is Cisco's. But I'm not going to do that. It's same like what we did in router 9 and router 6. But instead of that BSR candidate,
Synchronize.
IP PIM, I was using
Mm.
RP candidate and BSR candidate. Now you are going to simply use RP announce and RP discover command. That's the difference. This will use auto RP. Auto RP
Right.
uses a flooding method to discover the RP, show IP M route. This is by default enabled. We did not join this multicast group. This is Cisco router. So Cisco has enabled this so that using this address and 1.39, 1.39 and 1.40, by using this two multicast address, they can discover RP by flooding and learning. Once they learn RP, they don't flood anymore. It's not popular. No one knows about this except Cisco. But in the exam, they may ask you. And so the commands are, instead of BSR candidate and IPPIM RP candidate, we used to say IPPIM discover command and announce command. Announce is to do the announcement that this router is an RP. Discover command is to learn from the announcer and distribute to the other routers. It's called mapping agent. So if you use these two commands instead of RP candidate and
Mm.
BSR candidate, you will have auto RP. But the best one is using PIM itself. Why you need to use another protocol auto PIM itself. And one more topic which I want to show here is theoretically you can try later BSR enable. Okay, I think I can enable now itself. In this only I'm going to enable BSR. IP PIM. What will happen if I put this command on all routers? They will never learn source. That's all. See, if you have many source for the same multicast address, if you have many source, instead of learning all the source in the M routing table and consuming a lot of buffer, it will keep it as any. I'll explain it. But before that, I want to finish pasting it without missing on any router.
Mm-hmm.
Now, after putting this, you see, I'm going to ping from router 2. Router 2 is the source, but you will never see that source anywhere. Ping 239.1.1.1. So who is the source right now? Router 2 is the source. You will get reply, but routers will never learn source. See, you get reply, but if you go and ask router 5, hey router 5, who is your source? Show IP PIM, or show IP MROC. Come on, I see the source. You should not see the source. No, it shows the source. Something is missing, but that's the meaning of bidirectional ping. I use the command bidirectional enable, meaning in any direction source will be. So a group member can become a source can become a group member. For example, assume this as a conference room. Each router is a person sitting in the chair. In front of each person, there is a mic. Now, when this person on the mic, he becomes source. All the other members are group. Now, if all the router learns R2 as a source, now R10 owns the mic, then all again learns R10 as the source. Everyone learns another source for the same multicast. Now, when R1 owns the mic, means when R1 sends the traffic, again R9 is learned as the source. So now, if you check the M routing table, there will be 3 sources for the same multicast. To avoid this, we enable bidirectional PIM so that it won't learn source. See, because we are doing multiple laps in same topology without restarting, you are not seeing the actual output. If you shut down and start now, it will show you the exact output. We are using the same topology just by changing the protocols. Yes or no? That's why. That's why I'm not able to show you the exact result. I can even still see the source even after configuring VSL. That's the old registry, which is not refreshed, not cleared. Instead of clearing, you can shut down all the routers and start. Then it will be accurate. So there's nothing more in
Right.